Hello and welcome everyone. I would like to thank you all for joining today's webcast, which is Increased Reuse Rate with Holistic Variant Management. My name is Shivani Hegde, working as a field application engineer at Pure Systems, where I conduct trainings, presentations to help our customers with their journey towards a systematic variant management approach. Now, I would like to give it to Rachna, my colleague.
Hello and welcome everyone. My name is Rachna and I also work at Pure Systems as a consultant and a field application engineer together with Shivani, helping our customers towards their holistic variant management journey. Thank you.
Yes, so today the two of us would be presenting the webcast. And so, as you see on your screen, this is an overview of all the episodes of the series Mastering Holistic Variant Management in Engineering. Today is the second episode where we will discuss in detail on how we will increase the reuse rate with holistic variant management. Next slide, please. Yeah. So as shown, you can find all the upcoming webcasts on the website. They are recorded and also uploaded on our YouTube channel. And should you have any questions during the session, please feel free to use the chat system there. Only our webcast team would be able to see your question. We will collect them at the end and answer it after the webcast. And if there are any open questions left, we will follow up. So now let's just jump into the topic. Let's see what exactly we mean by systematic reuse with PLE. So as you might be aware, like as the complexity in engineering assets increases, it always demands for a better methodology to shape and drive sustainable businesses, right? So in today's webcast, we will see how we can maximize the success through systematic reuse with product line engineering in an easy and efficient way. So systematic reuse basically or mainly refers to the practice of efficiently leveraging engineering existing assets, components, and knowledge to develop a range of related products. It also involves creating a reusable core platform that serves as a foundation for all your product variants. This enables the sharing and adaptation of all the common features and functionalities across the product line while also allowing you all to do any customizations or any kind of differentiations that exist within the products. So now here we talk about the key factors that are involved. The first one is sustainability, cost, time, regulatory compliance, and and then quality. So coming to each of them, let's let's try to understand what we mean by them. So first one, that is sustainability. So with systematic reuse, it basically promotes sustainability by reusing the components with which you can reduce the resource consumption and waste. So now, for example, if in the application life cycle of a product or a system, we can reuse the common modules that exist between them across multiple product variants. This way, you're reducing the overall environmental impact associated with producing new components for each of your variant. So this is about sustainability. Now coming to cost, right? So here, reusing the components reduces development costs. And how? Because with development costs comes the expenses associated with designing, prototyping, and manufacturing. So here, what we basically do is we once when we reuse it, you don't have to really focus on creating new parts. So now, for example, if you're using a software for the self-driving cars, then here the software can be reused for multiple vehicle models, thus reducing your development costs associated with it. Next, talking about time. So systematic reuse, again, in product line engineering can significantly reduce your time involved in product development process. So here, for example, a software company who developing a suite of applications can reuse a common database, reducing the time required to write a new code from scratch for each individual application. Next, we have the regulatory compliance. By this, what we mean is that it can facilitate regulatory compliance by ensuring there's consistency and traceability across your product variants. So, compliance requirements can be integrated into reusable components, ensuring that all the product variants that are derived are made sure they meet these necessary regulations. For example, a medical device manufacturer can reuse a validated software module across his different devices, ensuring compliance with specific regulatory standards in each product. Then coming to the last one, that is quality. Yes, so systematic reuse also enhances the overall product quality through consistency and proven components. So by this, what we basically mean is that the components that are well tested can be in turn used across different product variants, and thus you have reliability among all these products, right? So now, for example, an aerospace company can reuse a certified avionics system across multiple aircraft models, ensuring there's consistent performance and safety standards that have been met across the product line. So now these were some of the factors, key factors, talking or telling us how it impacts us, and then by using the systematic reuse. Now let's move on to the next slide, where we will try to understand what do we mean by consistent reuse across the product development life cycle. So, in product development life cycle, assets look different across the tool chain, and achieving consistency in reusing the components and artifacts is complex, but at the same time, I'm sure you'll understand that it is essential as well. So now the ways of handling variability. Now, if you see in the V diagram, you will see, yeah, the ways of handling variability without a holistic approach might require you to configure product variants multiple times, such as maybe defining a special attribute in the during your requirement stage, or clone and own for design, defining preprocessor commands for implementation, and so on. So what happens here is that one must go through the challenge of configuring the variants on each level again and again. So to overcome these challenges is where product line engineering comes to play. And product line engineering, basically, it has a central place where you can store all the variability information. And as you see on your screen, it's the feature model. So yes, so this feature model and the lines that indicates it, so they are connected to all the different solution assets. And then this way, what happens is that you are connecting it across your development life cycle. Meaning, you can configure your variants using the features of your feature model in your variant model, and the appropriate assets are picked up for you just by one click, and then that is the process of transformation. So, using the transformation process, this entire thing works up for you. So, next, talking about the last point that I also would like to emphasize here is that the Pure Variants tool, the variant management tool, thus provides a powerful solution for maintaining and promoting this consistent reuse, irrespective of where you are in your product life cycle stage. So, because even though you're in any stage, you can easily connect to it without any hassle. So this was about the consistent reuse across the product life cycle. Now moving on to the next slide. Here we are just going to briefly talk about the talk about how we can master variability in 4 steps. So I'm just going to give you all a brief overview of how it works. Then my colleague Rachna will take you all through the demonstration, and we have a look at the tool directly. So here, coming to the first one, here, as I said earlier, feature model is somewhere where we store all the variability information. So thus, we consider the feature model as the single source of truth, right? So because since all the entire knowledge of the product line exists here in a very consistent and rule-based manner. And also on your right hand side that you see, you have this feature model, and here each feature has different icons next to it. So these are the variation types. So so we have four variation types. One is the mandatory, and then or feature, optional, and then we have alternative. My colleague Rachna will talk about it in detail. So here now the first step, yes. So we have the feature model, we have stored all the knowledge there. Then coming to the next step, we are going to connect this feature model to one or more engineering assets. By creating restrictions and so on. So this way, your engineering assets could be anything. It could be your Polaris requirements document, or it could be your architecture model, test cases, and so on. And we consider this engineering assets as your 150% superset assets. So once you've connected that, then we move on to the next step where we are going to configure our variant according to the required features that you want to see in your variant. So another best part of this is that while you're configuring your variant within Pure Variants tool, you will see how easily you can do it. It is also done in a very guided manner, and also the validation checks are automatically done for you. In case of, like, now for example, alternative feature, so if you select one feature, then the other features automatically excluded for you because it's either one of them that you select, so and so on. So then moving on to the final step. Now, after you've done all this, yes, you need your product variant, right? So finally, you can trigger the transformation, which does the mapping between the features and in the feature model and the corresponding domain assets. So once the mapping takes place, the 100% variant is generated from the 150% superset assets, and this whole process you will see that it is ensured in a very streamlined and precise manner. So yes, so these were the four steps on how you can finally derive your product variant. And with this, now I would like to hand it over to Rachna to do the demonstration.
Yeah, thank you so much, Shivani. So, as Shivani explained about the feature model in the very first step and its variation types, I'm first going to take you through the different types of features that you can model in this feature model. So, on the right hand side, as you can see, all the features with an exclamation mark would be the mandatory features. The one with the question mark would be the optional features. So by rule, it says that you can either not select any of them or select one or all of them. Then the green a double-headed arrow, that is the alternative feature. So by rule, you have to select at least one. And the last one is the blue cross, which is the or feature. And this means you have to select at least one, but you can select all of them also, right? And then on the left hand side, what you see is a feature tree. So this is what a feature model looks like, where we have the different kinds of features placed in there. Then we have some child features to some parent features. Then there are also relations that you can build. So for example, if there is some kind of dependency between different features within the same feature model, you can do that. Or for instance, you have divided your entire system into separate subsystems, and each subsystem represents a different feature model. Then you can also create this kind of interdependency. So now what I will do is I will just take you through a quick demonstration where I would like to tell you how can you reuse your assets. Okay, so as you see on the left hand side, we have automotive demo car light. So this is the product line car light that we are going to be talking about in this example. And then we have our variant project over here. We have the configuration space, and in the configuration space we store all of our variant models. So as you can see, the one highlighted, it's called base light VDM. So VDM is the variant description model, and on the right hand side over here you see what the variant model looks like. So this is what we are going to consider as our base variant model for the example. And then there are multiple ways how I can reuse this. So the very first one would be if I can just go ahead and clone it, right? So in order to do that, I would just go to my base model and then click on clone. And the moment I click on clone over here, you will see that by default, it will already get a name, which is called baselite clone. And since I have only one configuration space available over here, so I will store it in the same configuration space. And then all I have to do is just go ahead and click on finish. After clicking on finish, you now see over here that the initial variant model, which was called baselite, is now cloned, right? So all the selections that you see on the left hand side are the similar ones to the ones that I have on the right hand side. So this is a simple example. So of course, we have a simpler feature model over here, but you can also use this for more complex use cases where you have thousands of features in there, right? So now what I can also do after cloning is either I can have all my selections intact and then make more selections on top of that, or I could go ahead and also change selections. So maybe I selected fog light over here, but now I want to change the standard bulb to for this example, like for my clone, so the LED gets blocked, right? So this is one way of reusing the assets where you can just clone your base model, which will mean that some of your selections or most of your selections, you could keep them same and then build on it, or also go ahead and select or deselect more features. And then we also have a second way how you can go ahead and reuse the asset, and this is what we call as inheritance. So inheritance is another way where all your selections will directly be inherited but not cloned. So it will not be a copy paste, but more like they will be locked, right? So in order to do that, I will go to my configuration space and this time just create a new variant model. And the moment I click on new, it is going to ask me for a name. So let's say I call it Baselite Inheritance and click on next. The moment I click on next, you will see over here that because in my current configuration space, I just have two variant models. So those are the only available models I have here to be inherited. And then on the bottom, on the left hand side, you will see that it is also asking me to define the scope from where I want to inherit these variant models, right? So it could be the current configuration space or it could be the current project. So as I mentioned before, one project could have multiple configuration spaces. And if your project has multiple configuration spaces, you can just click on current project and it will show you all the variant models available in your project to be inherited. Or you could your specific variant project could also be referenced to others. So if you click on this, you will see the models from there, right? So now moving on, as I told you, we only have two models available over here. So I would just want to go ahead with base light in this case. So I click on base light and then inherit the selections. The moment I click on finish, you will see over here, so I would just like to highlight. So as you can see, all the selections which have been inherited have a small lock next to it, which basically means that you cannot change these feature selections. So let's say I try changing one, then a dialog box will appear over here and it will tell me that this selection cannot be changed. And the reason is that they are inherited. So then, let's say if I want to really change something in my inherited model, I have to go back to the original one, or the other way around. Also, if something changes in the original one, it will automatically get reflected in the inherited model. So let's say I change my selections in the base model, and now you see it also changed or did get reflected in the inherited model and it still stays locked. So that is the major difference between cloning and inheritance. And these are the two ways how you can go ahead and reuse your assets from the base model or reuse your feature selections in this case. And once again, as a summary, if you're going ahead with the method of cloning, it's more like you will still have the option to change your selections. But if you go ahead with inheritance, you cannot change your selections. But in both cases, you will be able to add on more features to it. And with this, I would now like to hand it back to Shivani. Thank you.
Yes, so thank you, Rachna, for showing us how we basically can reuse the reuse it and within the tool. So now we've come towards the end of the webcast. So let's have like a quick summary and see what all we covered. So now one might wonder, why is systematic reuse crucial at an early phase in product development? So that is basically to maximize efficiency, to reduce your costs, ensure consistency, and improve your overall product quality. So this basically you're doing it by leveraging pre-existing assets and knowledge, and this way you can accelerate development and also establish a solid foundation for your product line. So then coming on to the next one, what we saw was the feature models. How can we deal with complexity in engineering assets is through using feature models, because this acts like a single source of truth, because it has all the variability information stored within it. And then here also another thing is that in case of complex scenarios, you can have multiple feature models and also have relations between them. So then also we saw how systematic reuse contributes to building a sustainable business, as we saw how it can be really useful in different sectors as well. Then we saw the five factors that collectively contributed to increase efficiency. It also promotes sustainability, improves your reduces costs, and also development time. And in case of any adherence to regulations, you can easily do it once, and all your product variants will adhere to it. So then I would here now, since we've reached towards the end, Pure Variants has multiple connectors. As you can see on your right hand side, these are the different categories that exist. And yeah, so such as the requirements management, model based system engineering, office, test cases, test management. So yeah, so these are the different categories. You can have a look at it by going to our website, and there we have it in detail, and also there are short clips talking about each of the connectors, and let us know which is more suitable for your need. And you can always contact us at contact@puresystems.com, and we are here to help you all. So I hope you guys enjoyed the webcast, and with this I would like to wish you all a nice day, and thank you for joining again.
Yeah, thank you so much, everyone, for joining. And
Yeah.
yeah, if you have more questions, please feel free to write to us. Thank you so much.